Good afternoon, sir.
Good afternoon, ma'am. Good afternoon.
வந்துகிட்டே இருக்காங்க சார்.
ஒரு சார் ஜாயின் பண்ணலன்னு நினைக்கிறேன்.
ஹலோ சார்.
மேடம் இன்னும் சார் அவர் ஜாயின் பண்ணலன்னு நினைக்கிறேன்.
சார் அவங்க ஐடி டீம் ஜாயின் ஆயிடுச்சு சார். சார் வந்துட்டு
அவங்க என்ன பேர்ல
சார் ஒரு நிமிஷம் சார். இப்பதான் பார்த்தேன் அவங்களோட ஐக்கானோட. சார் முகமது அபு ஹனீஃபா அப்படின்னு ஒன்று இருக்குல்ல சார்.
எது மேடம்?
முகமது அபு ஹனீஃபா. அது அவங்க ஐடி ஹெட் சார்.
ஓகே ஓகே. அவர் என்ன சோசாலி டெக்னாலஜி இல்ல?
ஆமாங்க சார்.
சோசாலி டெக்னாலஜி. முத்துக்கருப்பன் ஞானதேசிகன். அவர் டீமோட இருக்காருல்ல?
ஆமாங்க சார். அவங்க ஐடி டீம் ஜாயின் பண்ணாங்க.
Sorry, sir.
Good afternoon, ma'am.
Good afternoon, sir. Abhirami sir, John sir, join பண்ணிட்டாரு sir.
Join பண்ணிட்டாரா?
Muthukaruppan Gnanadesigan சாரோட தான் சார் வருது.
சரி. Sir, good afternoon. Good afternoon, sir. This is Devaraj. Welcome, sir. Welcome to this webinar.
Thank you.
Once with the team members, hearty welcome. We will start the session as planned by 3. We'll have 10 more minutes to go.
Yeah.
So we will wait, and 60 people are joined. So start by that time only people will join. Okay, sir. Thank you, sir.
Thank you.
85 சார். Letter of discussion.
Good afternoon to one and all present in this session. Good afternoon. Abhi madam, Rahim ma'am,
Sir.
and Dr. Muthukaruppan Gnanadesigan sir. Good afternoon to all, and good afternoon to all the participants. Ma'am, let us start with our participants has reached 160 plus.
Yes, sir.
Okay, sir.
Shall we start, sir?
Definitely, definitely.
Okay. Ma'am, Abhi ma'am, you can start recording, and as soon as the recording starts, I will come. And then you will come and introduce the guest.
Yes, sir.
Then sir will take over. Questions at the end only. I will give brief instruction to the participants also. Am I audible clearly?
Yes, sir.
Okay. Okay. Nirmala, yes. Nirmala, yes is there. You can mute your video too.
Record करा रहे हैं. Sir,
Yeah,
start recording, sir.
Thank you, ma'am. Thank you, Nirmala. Yes, ma'am.
Sir,
Okay.
start recording me.
Recording.
Start करा sir.
Start பண்ணுங்க.
Okay.
Good afternoon, one and all present in this webinar session. On behalf of Easware Engineering College and Department of Electronics and Communication Engineering, I welcome Dr. Muthukaruppan Gnanadesigan sir and his team for this webinar. And my sincere thanks to him and his team also for accepting our invitation to be here today. And hearty welcome to all the participants. Some participants are repeated to our seminar and webinar, and then they are continuously supporting us. Thank you all and welcome. I welcome one and all to this webinar session. Just 2 points to highlight to the participants. One is that keep your audio, if possible, your video also in the mute condition. so that it will help the host to present properly, and you can ask the question at the end, because if you switch on the mic, everyone or more than 2 or 3 people at a time, then it will not be possible for us to manage. So chat, put your questions in the chat box, and the coordinators will ask the question on behalf of you by telling your name also. Thank you, and over to coordinators. Ma'am, please take over.
Okay, so thank you, sir. Good afternoon, one and all, and thank you for your presence at this afternoon session. It is my privilege to welcome Dr. Muthukaruppan Gnanadesigan, who is currently the head of Healthcare Division of Sosaley Technologies, Chennai. Sir has a very big profile, and I'm just trying to make it brief. Sir is a gold medalist in his undergraduate with biomedical instrumentation specialization. He completed his MS in biomedical instrumentation from Furtwangen University, German. Completed his Ph.D. in medical imaging and electronics from Erasmus University, Netherlands. He has many publications and mostly with the international journals. He is an active member of International Working Group for Intravascular Optical Coherence Tomography. He is closely associated with Central Electronics Engineering Research Institute and is also involved in product development for cancer, cardiovascular, and other therapies. We welcome you, sir, for this session. You can now take over the session. Thank you.
Thank you so much for the introduction. Thank you, sir, for having me. Am I audible?
Yes, sir, you are clear. Your voice is clear.
Okay, thank you. Thank you so much, sir. So on behalf of Sosaley, I would like to thank you for the opportunity.
Excuse me, sir. Little echo is there, and you can reduce volume also. Little echo is there.
Okay.
Uh, Thank you, all participants. You are highly disciplined, and you have kept your audio and video in the mute condition. Thank you. Please continue, sir. The participants list has increased across 207. It's a great response. Thank you. Thank you for the response. Over to you, sir.
Thank you so much, people, interesting people, try to live up to the expectations. Yeah, so I don't have a long introduction on the company, but briefly I will introduce our company. So we are Sosaley Technologies Private Limited. We are basically embedded IoT-based product development company. We have several verticals and like healthcare, automotive, industrial automation, and also recently we have added home automation also. So I am heading the healthcare division of Sosaley Technologies. I'm associated with Sosaley from I think 2018. Before that, as Ma'am said, I was junior scientist and did PhD there. And, I was in 8 9 years, actually 9 years in your company. Now I have a very good opportunity here at Sosaley to explore new products. Quite good so far. Today the idea is to share with you. Sorry, yes.
Sir, your voice is not so clear.
Okay.
Can you please raise the volume?
How about now? It's okay.
Okay, sir.
How about now, ma'am?
Better, sir.
Okay.
Some background noise is there, actually.
We are using our conference. I'll try to be more louder actually.
Now it is.
Now it is. Now it is okay, sir.
Okay. So I think this first. Okay, then I think we can jump into the presentation. is the slide visible to everyone?
Yes, sir.
Slide presentation is not visible, sir. You are on the screen.
Presentation is visible here.
I think I have started the screen. So, is it visible? Can I start? I think someone else has started.
Participants, please do not present. Participants, please stop
Mr.
presenting.
Sri, sir, please.
Sir, நீங்க என்ன நேம்ல presentation எடுக்க போறீங்க? Presentation login. அது சொன்னா எல்லா participants அதை print பண்ணிடுவாங்க.
Sir, Muthukaruppan Gnanadesigan presentation இருக்கு sir.
Okay.
It's in the name of presentation Muthukaruppan Gnanadesigan.
Okay, ma'am. Please, participants, print to that.
Okay, sir. Done. So, now is it visible? Yes, sir.
Yes, sir.
Okay. So, yeah. So, let me start. So, good afternoon, everyone. So, today I would like to share some thoughts about the current trends of healthcare and medical electronics in India, and also what would be the future, especially after this tough COVID-19 situation. What would be the emerging technologies that will take over in healthcare domain? So today's agenda, we have a short introduction to medical devices with current trends and what is the regulatory obligations in India, and then what would be the future trends, and then I will give some briefing about our healthcare products. So a couple of interesting products we have, and then I will take one of our product and then correlate it with with the subjects, with the technologies you learn in your universities now, so that you can you have an idea of how what you learn at college is being used in the industry actually. So that's how I would like to have the flow today. So to start with, there's also some information about where are the medical devices manufacturing is clustered in India currently. You can see it's south heavy. So Karnataka, Tamil Nadu, Andhra Pradesh, they are big players and they have hosted lots of multinational medical devices manufacturing company. And Tamil Nadu has even some our own domestic manufacturers, and then a couple of them are in Delhi also. And the multinational companies present here, they don't actually make all the large scale devices here. They make part of it, especially the software part and the GUI. But the actual device is usually registered in the home country, like Philips, they have it in Netherlands, and Siemens in Germany, etc. But part of them are researched and developed here. They have research centers in Bangalore and Hyderabad, and some in Chennai. So, currently in India, we have very few players who develop the whole product within the country, especially in large scale and also huge devices like CT, MRI. Those are yet to come up in Indian manufacturing sector. So knowing how we get our medical devices now, so we are heavily dependent on import currently. So there are lots of numbers here. The numbers are not so important, but I put this slide because we need to know that we are importing a lot of the medical devices, especially from USA, Germany. USA is the largest exporter to India, Germany, China, Japan, and Singapore. And we do export few of the small devices and some diagnostic kits, etc., to US and Singapore and a couple of countries. But the import-export, the balance is heavily on the side of import. So we import a lot, much lot than what we export. So that's how now government is also taking initiatives, to encourage make in India, especially in healthcare, so that we are not dependent on other countries for import. Actually, India until recently, till 2015, the medical devices sector was not regulated properly. There were lots of confusions in who is your regulator, whom do you get permissions, etc. So in 2015, they framed a draft committee, and what they did is they notified all the medical devices as drugs. So under the Drugs and Cosmetics Act. So they slowly started to notify, one by one all the medical devices under Drugs and Cosmetics Act, and so they define medical devices as anything intended for internal, external usage for diagnosis, treatment, or prevention, whatever in human and animals. They are all classified as medical devices, and they will be notified as drugs. Who is controlling this? Currently, the CDSCO, that is the Central Drug Standards Control Organization, CDSCO. They are the controlling agency, and then there are state level authorities. There are state drug control, drug inspectors, state drug director for drug control. They are there, and so what they did is they classified the medical devices into different classes. Like class A is of low risk, like thermometers, small devices operating on batteries, which doesn't produce much threat if used without much supervision. And then there are class B devices with low moderate risks, and then moderate high risk ones with have minimal invasive patient circuits like ventilators and other stuff like that. And then the high risk ones with radiological equipments and implants, heart implants, pacemakers. So those are classified as high risk. So currently, if you have a low risk, if you are manufacturing a low risk medical device, it comes under class A, and it's enough you go to the state authorities for getting the manufacturing license. And for B, C, and D, the central authorities are responsible for granting you permission for manufacturing and sale. So it's important to identify first your device, which comes under which class of device, and accordingly you have to get the approval from the regulatory authorities. And now it's being implemented strictly more and more, and you will end up with a huge penalty if you don't follow the proper channel for getting the regulatory permissions. So regarding manufacturing in India, there is now the demand is huge. So every country sees India as a huge market for healthcare, along with other domains, also in healthcare. And also domestic manufacturers are also trying to match up with the international players. So they have to always be innovative in terms of ideas and also in terms of manufacturing process. They should be able to manufacture quickly new materials and low cost but durable quality materials, and use advanced manufacturing technologies to compete with the other players. So they invest heavily in research and development. Even medium scale company like us, we have invested a lot in research and development, before even our product rolls out. So that has become more and more relevant. if you want to compete and match the international standards. So, what are all the current trends that is impacting the manufacturers here? So, the traditional devices are being slowly phasing out. Now the wearables, like wearable health monitoring devices, has taken over, and almost one in every 5 people have all these Fitbits kind of health monitoring, fitness monitoring wearables on them. And then there are a couple of other technologies which made possible certain things like MEMS and microelectronics. They have made devices much smaller and help to scale them down in terms of size. So if you look at wearable health monitoring devices, this is one huge potential market, especially now. Whatever we have is more for like fitness related monitoring, but soon there will be medically validated, clinically validated medical devices which can be used for domestic healthcare, like a personal use, but still it will be a medical grade devices. So the home healthcare will be a booming sector soon. So we have certain challenges before that, because you need to have miniaturized, easy to use, because people without proper medical training or knowledge will be using them. So it should not, it should not be obstructive to anything what they do, and also it should be easy to use, switch on, switch off, etc. But at the same time, the sensing capability should match the ones in the hospital environment. So that is a challenge. So you get the medical grade data, but in home environment. So that's a challenge, and also a challenge in terms of design and manufacturing, because you need to miniaturize things and get you need more power, but you have very less space and form factor. So you have to go through all those challenges in devising such wearable monitoring devices. And then of course you need to fuse technologies. For example, there are a couple of devices already in market where they are they are of in millimeters of size, and still they are able to communicate to other devices. There is communication ICs inside, and then they send. Hello. Hello.
So you can continue, sir.
Okay. Yeah. So there will be fusion of technologies, to achieve certain flow, because if you want, the data to be transferred to other devices, and if you want a couple of sensors, more than one sensors, all those challenges are there. So you need to scale down all the power supplies and power batteries and stuff like that. So that's one challenging area for people going towards the direction. Sorry, am I still presenting?
Yes, sir.
Okay, because I got a message.
Sir, everything is okay, sir. Your presentation is also on. You can carry on, sir. Thank you.
Okay. Sorry, I got a message that I am not presenting anymore, sir. Yeah.
No. You can, percentage very low. Miniaturization and implementable devices. It is there.
Yeah. Yeah. So there are there are situations now where you have lots of implantable devices for both diagnosis and therapy. And to be for them to be less invasive, you have to miniaturize the whole size. So for that, you need micro level electronics and small scale batteries, etc. So that's still being not much of them are available yet. So that's one. And when you go to micro nano scales and also new fusion of new technologies, the current quality inspection cannot handle those devices. So that should be evolved. So how do you quality check for a small laptop? And sorry. So and there is also a challenge of aging population. So in India, it's not of a much challenge because the ratio of young to age to population is still on the rise. So it's good trend. But in most of the Western countries, the aging population is a big problem. So you have to provide accessible healthcare to all of them, and still at low cost. You have to keep the cost low. And you need to identify their chronic illness, etc. So that's one of the challenges while manufacturing. You have to keep in mind. And also growth of emerging markets. So India is an example. So now the medical devices and accessibility to people to the healthcare products and to internet and smartphones have opened up lots of opportunities here. But the challenge is still the cost. It cannot be, for example, any FDA approved medical device will be of high cost because it takes longer time to get the approval. They spend a lot on meeting the requirements. So you have to have a revised kind of standards, and also to give there should be a set of governing rules for devices that should be sold to middle and lower income groups. There should be some easiness in getting the approvals and the standards for them. And as I said, the regulatory process in most of the countries is really cumbersome. It's very long, and sometimes there is lack of clarity. So that's something which has to be addressed. Otherwise, manufacturers will be the sufferers, because it's if there is no proper guidance, or if there is too much of effort to put to get the regulatory approval rather than the research and development. That doesn't sound well for the manufacturing sector. So these are the current trends that challenge and challenges that are faced by manufacturers. And to keep an eye on evolving trends, there are devices which come with a fee for value. Fee for value in the sense you only pay for the results and outcomes from a device that is really hello. Hello.
Sir?
Sir?
My presentation visible now? Because it often
Yes,
switches off. Okay. Okay, now it's visible, right? Yeah.
Yes, sir.
So so a couple of examples of the devices, there's one from St. Jude Medical, which prevents sudden heart failures. So the warnings from them actually help you, take preventive steps, and there is one from Boston Scientific also. There are these are devices which also affect the financial outcomes. So it reduces your hospitalization fees and stuff like that. So and also there is a trend of now being electronics being shared, and more data. It's becoming data heavy than electronics heavy. There is now a necessary for sharing the electronics and keeping to collect the data. Sorry. Um, so there are a couple of examples here. So what they do is they reduce the dependency on electronics and they increase the dependency on data, and also they collect data from different nodes, use data analytics on them, and have better prediction algorithms. And also they use advanced electronics also to reduce the manual error in surgeries. For example, the robot which is used for assist in knee replacement surgeries. So the current medical devices market globally, what is the emerging state? So the market size is more than 500 billion. Now the trend is to move towards digital health solutions, and you have to give some value. You have to really show the value of your product. So the outcome of your product should really have an impact. Otherwise, the times are gone when people blindly buy healthcare products. Now, there should be a clear evidence for the impact of the results, and also it is becoming more service oriented. So instead of doing outright selling, they they use the AI based algorithms as a service, robotics as a service, etc. As I said before, the medtech companies, they are now leveraging the data more than the device itself. So now the data has become the prominent thing in healthcare. And also remote monitoring. Remote monitoring is one of the future trends. I'll talk about that later also. And even established players who are traditional makers of many devices, they are now moving to IoT-based, cloud-based tools to view their data, to share their data, etc. And also making the diagnostics or therapy as a service instead of outright sale is also a current trend. And also, big players like Apple, Google, and everybody trying to come to healthcare. That opens up lots of possibilities. To use their strongholds like their cloud architectures, etc. So one of the emerging and very important trend in healthcare is the IoT, cloud-based devices. Here is some numbers of how it will reach almost 12.8 billion by 2020. And there are private clouds, secure clouds, more secure clouds from different companies that offer data protection, and the future is connected devices and shared data. So there are lots of opportunities, but at the same time there are some challenges too. So of course the cloud opens up opportunities for, as I said, collaborations. You can do data analytics on a large scale data. But the thing is still it has regulatory approvals which have not adapted to the new trends. So still the old FDA rules are there, and other rules which poses a challenge to the cloud-based systems. And also, when you use lots of connected devices, you gather up so much data, but you should know what to do with the data. So there are the new algorithms and new tools that have come up in big data analytics. They can help you, in predictions, in improving your product, etc. But at the same time, there are challenges of data security, data privacy, because especially in countries like in Western Europe, they have very strict rules when it comes to patient data security, etc. So also in terms of wearables, home healthcare monitors, etc. It's a huge it's a huge advantage for healthcare workers and also patient at home. But currently the standards that govern a particular type of devices, they are not fit for fit for evaluating the current advanced wearables and sensors. For example, the traditional ECG is governed by a set of IEC standards and also certain ISO standards, but the same cannot be applied to a device which even now we have made. It's a portable ECG monitor wherein your mobile phone becomes a ECG monitor actually. So there are certain adaptations needed in the current devices regulations and the standards that govern them. Some examples on what are the industry leaders, what are they investing, what are they moving towards. Boston Scientific, Medtronic, Philips, Siemens. More, and recently they have done a lot in cloud-based devices and cloud architecture. So that means they believe that going forward, connected devices, remote monitoring, cloud-based systems is inevitable. You cannot skip them. So again, I'm not presenting.
Sir, you can continue, sir.
Okay. Someone else is presenting. Yeah. And the other emerging technologies in healthcare is robotics. Nowadays it's not very new. Already we have seen robotic-based surgeries. And the once programmed rightly, they are very less prone to errors than manual operations. So it will be more precise and less invasive. And also, even now, the operator need not be near the robot. There are telemanipulators. He can operate it from somewhere, and then still the robot will do the commands. Some of the examples, there are surgical robots, and there are robots that disinfect, sterilize things, and also rehabilitation medicine. They have lots of assistive robots for ambulatory situations. And also other trend is that instead of old style of learning, there are new technologies being used in learning in the medical field. So, for example, cadavers are important, in training the medical professionals in surgeries and other also in anatomy and physiology related courses. But what they are moving towards is simulating the environment, So that it is not limited to, so if you have a cadaver, it's only limited to a batch of people, and then it will take time. But simulations can be accessed by everyone at the same time, and it will reduce accidents during surgery, and it makes training sessions more customizable and shorter duration. So some of the simulations available in the market for training, and also apart from these, there are also some companies which are now making products based on virtual reality, to train medical professionals. Actually, you will feel the actual pressure, actual cadaver on your hands with the help of actuators and specialized gloves and the virtual reality assistance. So those technologies will definitely will be a positive advancement in learning. And the most important future trend will be telemedicine. So, what is telemedicine? Telemedicine is gathering information of a patient or any medical related information, and it's electronically communicated to a node to another device, and that helps in the improvement of his clinical status. So it can be using video calls, using sensors at one end, and it can be monitored at the other end. There are lots of forms of telemedicine, but that is a certain trend that will come up, and especially in country like India. In India there are lots of rural places. There are places with less accessibility. This is going to be inevitable advancement, and the telemedicine will reduce the cost, will reduce the trips to the hospitals, hospitalization cost, and also it will give you more control and digitized medical records, more efficient. But still, there needs to be much more done. But still, that will that's going to be the future. Especially, recently also we had discussion with the player who is part of the Arogya Setu app, and soon what they are going to do is they are going to connect your Aadhaar, your national insurance scheme, everything to the single app, and that app will act as your personal, telemedicine portal. It will happen in couple of years of time. So there's a start already in the country. Usually how it is done. So if a person needs clinical care, but from distance, so you use actual doctor coming live in the video, or paramedical staff recording your symptoms, and in rural areas using mobile networks. So the the transfer of patient information from one place to another happens. So it can be just a simple symptom related information. It can be images taken of the patient, and sometimes the doctor comes live, and there can be video telephony between them, with interacting, and sometimes there will be sensors at different places, and there can be a analytical tool running on a server, and many clients will send accurate data, and the analytical server will do all the analysis and give the prediction, etc. So also in home healthcare, so it's going to be soon affordable, and yeah. So I'm sorry, no longer presenting again. அதான் அது யார் பிரசன்டேஷன் டேக் ஓவர் சொல்லிட்டேன். Now I hope again I'm presenting this. So what does telemedicine offer? So it offers four fundamental benefits. So it's improved access, to rural areas and places with long distance from affordable healthcare. So it gives easy access, and also it reduces the cost, hospitalization cost, trips to the hospitals, and also in due term it will become it will have since it is a digital record, it will have more data analytics, which improves the quality of diagnostics, etc. So and also there will be soon lots of demand for home healthcare and remote monitoring. So soon it will be a reality that your smartphone will be a smart tool for medical. Sorry, again I'm. Someone took over the presentation. Yeah.
Participants, please don't present your screen so that his presentation gets disturbed. Kindly cooperate.
Thank you. The future trend that will be that your smartphone will act as your one stop portal for your healthcare needs. So that will be the future. So having talked about the trends around, I will walk through what we have in Sosaley Technologies, what we develop. As a healthcare expertise, what we do, we do turnkey manufacturing. So from idea to a product, we do all steps in between. So we have software development, hardware development, embedded hardware development. We do data analytics. We do pre-clinical validation, clinical validation, and we have our own IoT architecture. We have our own IoT platform. So any devices, healthcare or automobile, any domain devices can be connected to our cloud, and the data can be viewed and analyzed. So one of the first products, so it's automated external defibrillator. You would have seen some of them in some malls or in some public places, but most of them are from Philips, Medtronics, etc. What we did is we got funded by Department of Science and Technology through Anna University. So we have tie-up with the Department of Instrumentation, and then we jointly developed a indigenous low-cost AED. It's a prototype. Actually, what I'm showing you is a prototype, not the actual device. But this device has much more than what the current market devices give you. It will show you live ECG. It will give you audio commands in 3 different languages. You can choose the language. You can store the ECG, and also based upon the ECG, it will classify your ECG and tell whether you need a shock or not. If you need a shock, how much? So what we do is we sense the transthoracic impedance. So that means how much energy your body can take. So we will sense that, and then that will be the first shock. So we give you a shock and then give CPR, and then it will repeat. So it is a full-fledged automated. It's fully automatic external defibrillator. And it will be the lowest in cost among current market products. That was the idea. And also we are now miniaturizing the device. We also have collaborations with the professor in Anna University who is expert in making drones and drones for different applications. And we are making it lightweight and compact so that it can be lifted by a drone and delivered to locations where it's not accessed easily, like a drone ambulance. And you can have a SOS app in your mobile, and if you can press it, and then a drone ambulance will reach you by locating you. So that's some future development in mind. And the other product we have developed is together with the CSIR CIRI, the Central Electronics and Engineering Research Institute, with Dr. Bala, who is a principal scientist there. So what we developed is a combined driver and truck monitoring system. So what we are good at is truck monitoring. So monitoring the truck's battery, its parameters, and track the truck GPS locations and door close open situations. But and together with Siri, what we did is we added a camera in front of the dashboard, and that will run some AI based algorithms, and looking at the eyelids of the people, of the driver, and his face movements, and it will predict whether he's tired or fatigued enough, and if it is there, then we give alarm inside the truck and as well as to a central command, so that he immediately stops the truck, so he is no more fit to drive. So it's like a driver assist system, advanced driver assist system. What is, so it will give you a driver sleep awake status. It will we have a conductive material in the steering wheel, so that his heart rate will be detected, and that will combined with his sleep awake status will predict the fatigueness. And also we add door sensors and GPS locations, and also battery related parameters. We watch the battery of the truck, for voltage, current, temperature, etc. And the flagship product of our domain is the hot Tarang, the wireless ECG. What it is? It is a portable, very small device. So I have a model of it. It's a very palm type device where you connect the usual 10 electrodes to acquire the 12 lead ECG, but it is connected to the box, and the box receives the data. We have our motherboard which do signal processing, and then send the data via Bluetooth to your smartphone. So your smartphone will be the ECG monitor. So what are the applications we kept in mind while developing it? So in country like us, we have lots of rural areas which are not accessible to the full-fledged ECG devices. There are lots of medical camps conducted by government, NGOs, etc. At that time, you cannot carry a full-fledged big ECG device, and this is a pocket-sized device. So you can take it anywhere, for such medical camps. Acquire the ECG. So that will come to your phone. From there, you can generate PDF report, ECG report, and you can share it with the consultant, cardiac consultant. You share it with anyone via WhatsApp. You can print it out, whatever you want. So this is actually the flow diagram. So you acquire the ECG, do some signal processing, transmit via Bluetooth. You view the ECG in your mobile, and then you can push it to the cloud. We have our own healthcare cloud where the patient data can be stored, and then you can do real-time analysis on the data. You can print it out. You can save as PDF. It's a portable, compact 12-lead ECG. To take you a little bit more into the device, because I want to correlate the subjects you learn in the universities to what is being implemented in the industry during product development. So this is the device which comes with the 10 electrode cable, which is connected to one of the ports here, and then you can charge the device using your smartphone charger. It is same as your smartphone charger. And this is actually a snapshot of our app, which you will be installing. It's Android based app, and you can monitor each lead. You can create ECG report, which will be on the standard format which doctor understands. So to take you through some of the modules inside this. So basically, I have to introduce you to biosignal. So signal is any function that conveys information about anything, sense anything of a phenomenon. So what it senses. In case of biosignal, it is any biological quantity which varies with time that gives some information about the biological systems. And usually they are a bit tough to handle because they are in the order of millivolts and also noise prone. The movement of your body, your breathing, and everything will contribute to the noise in biosignals. So these signals, they continuously pass between various parts. It can be electrical, it can be molecular signatures. In nervous system and cardiac activity, it is electrical. So you basically measure the polarity between two points, and these measurements are very vital for diagnosis and also for later research. So I have added an example of ECG. What it depicts. So the P wave, it depicts the depolarization of the atrium. So that's when the atrium starts to contract, and then the ventricle starts to contract during the QRS complex, and then the relaxation of the ventricles during the T wave. So these are understood by the trained professionals, and if there is an abnormality in the signal, that will be also read by the trained people. So what we do, so as I said, it is prone to noise due to various factors. So respiration will create noise, power supply will create noise, and there are lots of factors that induce noise. And we also faced such challenge when designing this. So we had lots of high frequency ripple in the baseline of the ECG. So what we did, we designed a low pass FIR filter. So you would have studied in signals and systems. So there is a FIR filter, and we used the EQ ripple method because the noise was in form of ripple. And also we should keep in mind the frequency we want. So we should know the start and stop band of your vital signal, and then usually when you do filtering on a signal, there will be a phase shift. So in term, but we cannot afford that in biosignal. So we what we do is a zero phase filtering. So we do some compensation, you know, to for the time shift, phase shift. And so what we did actually, because we continuously get the ECG and then we show it in the mobile phone, doing it in real time will definitely limit our capacity to data transfer. So what we did is we designed the filter offline in MATLAB. We took many samples of the signal. We derived the filtering coefficient, and then once the coefficients were finalized, we took only the coefficients and did the convolution with our ECG signal in real time in embedded systems, actually in embedded C. So the result was very good. So that's actually one of the samples from our device. So this is the original waveform, and after filtering, this is the waveform now you see in the device. And also, so you know, as most of you are ECE, so you would have introduction to embedded system. So it basically has a MCU. It has input from, you know, sensors and various inputs, and it has analog to digital converters inside. And then you do some processing, and then you give the output in form of, you know, LCD, LED, ARCs, just data. So there are like SPI, UART, and I2C. So all these form the part of the embedded systems which is present inside. And in this case, we also use multiple interconnection, because so we from embedded systems we have a Bluetooth SoC, a system on a chip, which sends the data to your mobile phone, and from mobile phone you can push it to the cloud. The data is pushed to the cloud if you have cloud subscription. So this is what happens inside the device. And Bluetooth, so in terms of, for example, keeping in mind the projects you will do in the university level, Bluetooth based projects are one of the easiest to implement, and there are now lots of development kits and SoCs available, you know, especially BLE 5.0, which has a transfer rate of up to 1.4 megabits over there. And it is optimized for low power. It will sleep awake for fixed intervals. And the range is quite good. So up to 10 20 meters you can get a good signal. And the good advantage is that you can always use your smartphone as a receiving end or whatever you want to show. So that it makes your life much easy. You know, so you can make proof of concept for many variables, health and fitness monitoring. You can do endless things with Bluetooth and development kits. So it gives you interoperability, and it operates at low power, and you can add more layers of security to some extent, medium level of security there in Bluetooth. So what else in terms of you know, in terms of ideas in medical applications, you know, it's now the trend is to add a wireless. You add a Bluetooth, Wi-Fi, or anything to make it wireless. And even established medical device producers, they are going that route, and it is more appealing to the customers. For example, these are some example cases for ECG, the Holter monitors. There is a patch where you stick it on your body. It takes your temperatures and other important parameters. And then there is the chest and wrist straps for monitoring your vital parameters. Here is some of the requirements you need for making such devices. Nowadays, all the MCU manufacturers, they come up with development kits which can be bought easily, and you can try out these things by yourself. Regarding some of the project ideas in healthcare, some suggestions what I have is, instead of going for something big, I would suggest to identify, the practical challenges in country like India. We have huge population, we have huge rural population. We have gaps in accessibility to high-end healthcare devices. And there are lots of gaps to be filled in. There is less rural reach, and there are lots of elderly people who are not familiar with the technology. So they had to be made easy to use for them, and there are people who don't know about the advancements in the medical devices. So find such a gap, find such a small challenge, that you can fix. Try to fix small but very necessary problems. Don't take up a big project. And there are lots of tools available in the market. There are single board computers like Raspberry Pi, Beagle. There are development kits from the MCU manufacturers, and there are open source development tools. There are open source repositories in GitLab, GitHub, etc. And when you make a project, it's the idea that matters. Don't worry about all the packing and the aesthetic. I've seen lots of guys spending too much on the outer appearance, but it's the idea that matters. And also, I would suggest don't try to punch above your weight. In the sense, don't take up very high-end technologies and the new emerging unexplored like blockchain. I have this and that. You take up in the domain where you are familiar with and a little bit about what you have learned at your university. And also don't make things that are irrelevant. You just make it and it just it's there in some rack for years. So try to make it relevant to the current market trend, and keep in touch with the industry for what is happening. Same if people are interested in research. I should say that I have limited knowledge and experience about research in India, but generally from my collaborations, I have found some of the institutions very good for research in healthcare, especially the Central Electronics Engineering Research Institute and other some of the Central Research Institute. They are doing very good in advancement of healthcare. And of course, IISCs, IITs, NITs, they have good biomedical instrumentation departments. And we work closely with the NHHID in Anna University, which is the National Hub for Healthcare Instrumentation Development. They help a lot for people who want to explore things in healthcare. There are only 2 centers in India, one here in Anna University, Guindy College, and one in PGH Chandigarh. And also state apex universities like Anna University, MIT, they also have good enthusiastic departments who are working, doing lots of stuff in healthcare advancement. And also there are some DST funded laboratories which are doing lots of research activities. And also in research, if you go for research, don't always wait for a very breakthrough research. This should be very different, etc. Because I know several people, faculty members especially, who want to do PhD. They spend a lot of time in just choosing the topic. They are not convinced whether it will make them look good, etc. You always now you can only do incremental research. You cannot go for a big breakthrough. Look for some small advancement which you can make, and also, if possible, don't take up topics which are dependent heavily on an instrument. For example, electron microscopy or something, which expensive instrument you need to run your. Make it instrument independent research. That's some of the suggestions I have for people who have research interest. And with that, I would like to conclude my presentation. Thank you, people, for listening. Thank you for SR Mishwari faculty members for the opportunity. Yeah, thank you.
Thank you, sir. Thank you very much. It is highly what we call information packed presentation. Thank you very much. Still, there are 248 participants in the list.
Okay.
The maximum 250. That shows their interest, and thank you, participants, for your interest.
Sure.
Now, Abhinam, you can post the link for feedback and the questions which you can ask in the chat box. They're there, and it is four time. Another five minutes you can have. We don't want to disturb sir for a long while. You can ask 4 or 5 questions, please.
Sure.
So, the first question is from Mr. Shafin Khadir.
Okay.
He asked how to approach NHIIT, sir. Is there any
NHIIT. Okay. Okay. I will actually send you an email ID of the person in charge here. Maybe you can share with your people. It is actually located inside the Ginti main campus, and the in charge of the NHIIT Chennai is a close collaborator of ours. So I will share his contact ID. Maybe you can pass it on to people who are interested.
Okay. So next question.
They are very good, very enthusiastic.
Thank you, sir. The next question is from Ms. Vidya Rani. What is interoperability?
Interoperability. Okay. So that means previously the device a single device has all the input, it has the output, it has the screen, everything. But now you can you divide those things so that it becomes compact and you don't have to carry a huge device. But the communication protocols like Bluetooth, Wi-Fi, they enable this interoperability, right? So that's why.
Thank you, sir. There is another question from Mr. Venkat Prabhu.
Yeah.
Why are we giving more importance to Bluetooth? Where is GSM module used?
GSM module?
Where is GSM module used?
No, we don't use the GSM module. That's why we send the data to the mobile phone, right? From mobile phone, you use the mobile data to push to the cloud. So the device has only Bluetooth currently. So it will just acquire the data and then push it to the mobile. Mobile has the GSM communication, right? So that's why mobile has several advantages. Once the data comes to your mobile, you can use it locally, store it locally, you can push it to cloud, you can share it with anyone.
There is one more question from Tek Rokaya. What could be the future of medical electronics?
Future is definitely towards miniaturization. So there will be lots of microelectronics involved, and also low-powered devices, which will which has to work continuously, like patient home patient monitoring. Those will be the trends. So it will be easy to use, compact, personal use medical electronics. That will be the future.
There is another question from Rohit Sai.
Yeah.
What type of coding languages should we know? That is what he means.
Yeah.
So
currently, when you use microcontrollers, MCUs, it's still embedded C that is the prominent one. So it is very easy to use. It is easy to create logic in embedded C. If you are using single board computers like Raspberry Pi, etc., which already has it needs some operating system. You can put a lightweight Linux on them, and then you can use Python like languages to interact with the embedded systems, or you can use RTOS, real-time OS. But embedded C is the most common in the industry till now.
There is a question from Satvika. In medical electronics, can we replace Wi-Fi with Bluetooth?
It depends on your range. So Wi-Fi has a wider range, but Bluetooth, yeah, if your devices which are interacting is within 10 meters, Bluetooth, or now Zigbee. Zigbee is also another option for the communication. But it depends on. If you are going to use mobile phone, either Wi-Fi or Bluetooth is okay. If you use Zigbee, then you need a receiver too. That Zigbee will not be available in your mobile phones or tablets. So Bluetooth or Wi-Fi is advisable if you want to move to remote monitoring.
Okay, sir. No other questions I can read from here. There are so many thank you messages. Actually, sir.
Ma'am.
Sir, questions in English, sir.
Sir,
Ma'am, any questions from you?
yes, sir.
There is one more test. Already we have exceeded the time, and
I see one question from
Yeah.
yes. So yes, to answer you, so we are getting when the products are getting certified, the EMC EMI has to be tested. So we are going to get CE certification for this ECG product. So at that time, we have to get EMI EMC certified, and there are NABL accredited laboratories. Even in Chennai, there is an institute called SAMIR, which is a central government institute. They do EMI EMC, and they also do in automotive central electronics ETDC. ETDC is also a place where you can do all those testing, and other electronics related testing are done in IIT. So we go through all those processes before going to the market. Of course,
it is going to be mandatory in future, sir.
Yeah. So if you now it is mandatory virtually, because if your product is not CE certified, or if it is not according to IEC standards, for example, for ECG it is IEC 6060125. So if you are not according to those standards, you are not going to compete with others. So when we manufacture, we keep that in mind. Actually, we make 4-layer boards to suppress those interferences, solid ground layer, and we separate power supply and ground. So we take some measurements, and there are sets of standards which govern them actually.
So there is another question from Mr. Heyman. Any simulation tools for medical electronics?
Currently, MATLAB has simulation tools, and of course, if you want to see, medical electronics is still an electronics, so PSpice will also do the stuff. So if you want to check your circuit, there are lots of simulation tools available already. For example, what we do for ECG is we have a standard set of database from MIT and other universities. So the outcome of our device will be quantitatively analyzed with the ECG standard ECG waveforms, and then that's how we evaluate biosignals.
Thank you, sir. Thank you very much. Almost all the questions were also answered. Very nice session, nice presentation.
Thank you so much. Thank you so much. It's our pleasure.
And we can see in the chat box, every people have thanked you for.
Thank you. Thank you so much for the interest, and it's nice to see so many enthusiastic.
Yes, sir. To keep our people easy, people active even in this time. So over to coordinators, please. Post vote of thanks, please.
Yes, sir. So, good evening to all. First of all, I would like to thank our management, principal, and our beloved HOD for granting us permission to organize such webinars. I also personally thank Dr. K. Raginisa Madam for her contribution in coordinating this event along with me. I also express sincere thanks to our department faculty who support this enormous to organize this event. And my sincere thanks to Dr. Muthukaruppan Gnanadesigan sir for rendering his valuable time in delivering this session. And I also thank Mr. Jagannathan, Sosaley Technologies, who coordinated with us for organizing this session. I would like to thank all the participants for attending this session among their various commitments. Since maximum of 250 participants can be connected through Google Meet, we were unable to connect most of your friends. So please convey to them that we are unable to connect them. Thank you all. And once again, I thank Sir for his contribution. Thank you, sir.
Thank you so much. Thank you for the interest.
Thank you, sir.
It was a pleasure. Yeah, thank you.
Thank you, ma'am.
Thank you, sir.
For some more participants, there is going to be 2 webinar sessions tomorrow from 10 to 11 IoT for COVID-19 and from 4 to 5 p.m. recent trends in cryptography will be organized from our department side. The participants, those who are there, please you can join by tomorrow. Thank you. Thank you, Muthukaruppan Gnanadesigan sir, for your energy through our 1 hours from the time of joining. Thank you very much. Thank you all. Now, Abhinam, you can start recording and then we wait for participants to leave. So you can also leave, sir, if you want. Thank you, sir.
Okay. Thank you so much.
Please submit your feedback before you leave the session.
Okay, thank you.
Thank you, sir.
Thank you.
Abhi ma'am.